Hi everyone, this is Himanshu and this talk is about Kafka. So first of all, this talk is not about implementation of Kafka concepts. We won't be seeing any code in this talk. It's mainly to understand how the various concepts in Kafka work. The talk is for people who want to get a deep understanding of how Kafka works and how various components solve the problem in distributed systems communication. So starting with the topic. A topic in Kafka is a logical way of separating how the messages are stored. A topic can have one or more partitions. Partitions within a topic distribute the messages to scale the consumption of messages. Whenever a producer publishes the messages to a Kafka topic, it lands in one of the partitions. The partition is decided based on the partition key. If two messages have the same partition key, then both the messages are guaranteed to land in the same Kafka partition. As a result, you can have ordering of events. If no key is provided, then the messages can land in any partition and it might be consumed by the consumer in any order. So a producer can produce a message in Kafka and it has the following: a partition key, which is optional, the message data itself, and a timestamp which gives the information of when this message was pushed to the producer. The producer can have various levels of acknowledgement. First one would be acknowledgement 0, which means the producer doesn't wait for any acknowledgement from Kafka that the message has been persisted. This method is fast but has a high chance of data loss. Second is X1, which means the producer will wait for an acknowledgement from the leader. This is still fast and have very low chance of data loss. Third is X-1, which means that the producer waits for leader as well as follower for acknowledgement. This would have the highest latency but no chance practically of data loss. Talking about the leader and follower, a Kafka topic is inside a broker. Broker in Kafka refers to a server in the cluster. Kafka runs as a cluster with many brokers to prevent message loss in case if a broker crashes. Let's move on to one of the most interesting bit, which is the consumer. Consumer in Kafka has a topic name from which it is consuming messages and a consumer ID. Whenever a consumer is created, it attaches to a partition inside the topic and starts pulling messages. Once it processes the messages, the consumer advances the offset to the next position in the topic. An offset is associated with the consumer ID. Let's talk about different scenarios to understand the consumption and partition better. Let's say we have 3 partitions of a topic and 3 consumers with the same consumer ID. This group of 3 consumers is known as a consumer group. Here each consumer will attach to a partition and start consuming messages. On each partition, we will have the track of offset per consumer ID. So in cases any of the consumer goes down, it can start processing from that point onwards, avoiding redelivery of messages. If we have a similar scenario where we have 3 partitions and 3 consumers, but the consumer group ID for each consumer is different, then each of the consumer would attach to all 3 partitions and process the messages individually. If we have more number of partitions than the consumers with the same group ID, then one of the consumers will be attached to more than one partition. If the number of consumers with the same group ID is greater than the number of partition, then one of the following consumers will be idle with no partition attached. In Kafka, once a message is processed, it's not deleted by default. You can configure this behavior to following at most once delivery, where a message won't be delivered more than once, but there can be message loss. At least once, where a message is guaranteed to be delivered at least once, but can be redelivered multiple times. Exactly once. As the name suggests, a message only will be processed exactly once. This was all about the Kafka concepts. I hope you liked the video. Thank you.